So how to reject the image on higher side and lower side? So we have seen that the LO frequency is always above the desired channel. So omega LO can be chosen below the desired channel. So you can choose the omega LO depending on whether it is going to be above or below. And we have seen that the difference has to be equal to omega IF. So choosing omega LO above RF or below RF does not make any mathematical sense to my system, right? So it is not going to change anything. So I can choose omega LO above the desired channel frequency or the below the desired channel frequency. So if you are going to choose it above, it is called as super side injection or it is called as super 9. If I am going to choose it below the channel frequency, it is going to be called a low side injection or it is going to be called as infra 9. The choice of one another can be, you can deal with the two scenarios based on the available bandwidth, what frequency you have, the strength of the image signal and other requirements. So two scenarios are there to reject your image. One that can be chosen based on omega LO because omega LO lies in midway between your signal and the image, right? So everything will depend on the choice of omega LO. So if you are going to choose omega LO above the desired channel frequency, you call it a superdine. Below means you're going to call it as infrared. So two technologies are possible. Now we are going to focus on image rejection. So how I can reject the image signal by in the receiver if the condition omega IM equal to omega LO minus omega N is perfectly satisfying in my system. So the frequency in such a way that the equation is perfectly satisfied. So how can I reject the image? So only thing is you have the local oscillator frequency. So only the choice of LO can lead to image rejection. So what local oscillator frequency I'm going to use that that has the extreme freedom of suppressing the image. The most commonly used method is, if you want to remove some unwanted frequency, you will have a filter. The same thing we are going to use it here. So at the receiver after LNA have an image reject filter. So which is going to reject your image signal and before mixing actually have a filter. So before you do the mixing operation, have an image reject filter. So this image reject filter will filter this component alone and it will pass the message signal to your mixer. So finally, you will have sum and difference component. You can filter out the sum component using an LPF. You can take the difference component and use it for further processing. Very, very simple technique. You can use it for image rejection is using an image reject filter just before the mixer. It's a very simple technique, but this also has a lot of disadvantage because you never know the exact image frequency. So this filter has a very small loss in the desired band. Filter has two bands, pass band and stop band, right? So pass band is going to be the frequency which is going to pass. In that frequency, the loss is going to be very, very small. And the frequency which is going to stop, in that the attenuation is going to be very, very large. Okay, so we are going to ensure that this filter is going to pass this frequency easily and attenuate this frequency very heavily. And this filter also ensures that it works in the frequency. It works very well in this frequency band of the desired signal. Or you can say that it is going to reject my image frequency completely. I am having here, see, the architecture is LNA followed by filter. So can I swap these two blocks? Can I have a filter first and then followed by LNA? So LNA is going to amplify whatever it is going to come in. Why I need to unnecessarily amplify by noise and then filter it? So if I filter out my signal and then amplify, I will amplify only my signal, right? So there is a possibility to swap these two blocks. Can the filter be placed before LNA? Yes, it can be done if you are going to save some power because of amplifying your noise